Hey everyone, and welcome to The Explainer. Today, we're diving into something really cool, especially if you're tackling 8th grade math. We're mastering TEKS 85B, which, if you don't know, is all about compound inequalities. But here's the fun twist. We're not just crunching algebra today. We're actually going to use these math concepts to build some character and wisdom at the exact same time. It's a true dual-purpose journey, and I am absolutely pumped to guide you through it.
Okay, let's anchor this whole thing with a really powerful thought from Philippians 4:5. It says, "Let your reasonableness be known to everyone." Now, you might be thinking, what on earth does reasonableness have to do with an 8th grade math lesson? Well, think about it. Life isn't usually about living in the extreme edges, right? It's rarely all or nothing. The healthiest parts of life are actually about finding and keeping balanced, wise boundaries. And mathematically speaking, that is exactly what we're looking at today.
So here's our agenda for the explainer. First, we'll welcome you to the middle zone. Second, we're going to unpack and versus or statements. Third, we'll actually solve some compound inequalities. Fourth, we'll graph those solutions. And finally, number 5, we'll wrap up with some wisdom for the mind.
All right, let's jump straight into Section 1. Welcome to the middle zone. We're going to explore those mathematical spaces right in between the extremes.
So what exactly is a compound inequality? Basically, it's a 2-in-1 inequality that helps us pin down a very specific range of values. So instead of just making a simple, open-ended statement like x is less than 10, we're bringing two distinct conditions together into one single package. It perfectly describes a middle ground, a specific zone where things are, well, contained and balanced.
And this beautifully illustrates why this matters in real life. Think about the middle zone, kind of like going out to grab a bite to eat. You might look at a menu and think, okay, I want my meal to cost between $10 and $20, right? You've got a lower limit of $10 and an upper limit of $20. You don't want it to be super cheap and lacking quality, but you definitely don't want to blow your whole budget either. That sweet spot right in the middle? That's literally a compound inequality functioning in your real life. It's practical, it's reasonable, and it's perfectly balanced.
Moving on to Section 2, Understanding and versus or. This is where we look at the two distinct paths these math statements can actually take.
Notice how these two fundamental behaviors are basically complete opposites. On one side, we have the and scenario, and on the other, the or scenario. For an and statement, both parts of the inequality absolutely must be true at the exact same time. It's a strict overlap. But for an or statement, only at least one part needs to be true. It's an either-or situation. They are total opposites in how they shape our middle zone, and honestly, understanding this difference is the secret to mastering the whole topic.
Let's look at an and example to make this concrete. 2 is less than x, which is less than 6. A much easier way to read this is just that x has to be greater than 2 and less than 6 simultaneously. If we picture this on a number line, we drop open circles at both the 2 and the 6. And why are they open? Because our inequality doesn't have that little or equal to line underneath it, so x doesn't actually touch those numbers. Then we just shade the area right in between them. It's this perfect continuous middle zone of overlapping truth.
Now, let's see how this changes when we use an or example. Here we have a statement that says x is less than -3 or x is greater than 4. Look at how this pushes completely away from the middle. If you graph this one, you don't get that nice shaded zone in the center. Instead, you get two arrows shooting out in completely opposite directions. I mean, you mathematically can't be less than -3 and greater than 4 at the exact same time, right? That's exactly why it's an or statement. You're either on one path or you're on the other.
Okay, Section 3, Solving Compound Inequalities. Now that we know what these look like conceptually, let's roll up our sleeves and actually solve them. So the main goal when solving is figuring out how to isolate our variable, x. Take a look at example 1 here. This is an and statement. 1 is less than or equal to x plus 2, which is less than or equal to 5. How do we solve this? Well, the golden rule is that whatever you do to the middle, you absolutely have to do to the left and the right sides too. So step 1 is to subtract 2 from all 3 sections. 1 minus 2 gives us -1. The middle leaves just our isolated x, and 5 minus 2 gives us 3. So our final clean answer for step 2 is -1 is less than or equal to x, which is less than or equal to 3. Boom, we've found our balanced zone.
Let's keep that momentum going for example 2. This one's an or statement. X minus 1 is less than -4, or x plus 2 is greater than 10. We tackle these as two totally separate mini problems. Step 1 is to collect similar terms. And here's a massive pro tip for you. Whenever you move a number across that inequality sign, you have to change its mathematical sign. So that -1 crosses over the less than sign and becomes a +1. -4 plus 1 means x is less than -3. Now on the other side of the or, the +2 crosses over the greater than sign and becomes a -2. 10 minus 2 is 8. So our final step 2 result, x is less than -3, or x is greater than 8.
Which brings us to section 4, graphing the solutions. Let's transition from crunching those numbers to actually visualizing our solutions on a number line.
Let's graph example 3 together. We need to graph the statement 0 is less than x, which is less than or equal to 5. Now, the details here are absolutely crucial. Because x is strictly greater than 0, we put an open circle right at the 0 mark. That just means the solution gets infinitely close to 0, but doesn't actually include it. But look at the 5. X is less than or equal to 5. That tiny little line under the symbol means we have to drop a solid closed circle right on the 5. And since x is sandwiched right between them, making it an AND statement, we confidently shade that entire middle zone between 0 and 5. Seeing it visually like this really brings the abstract math to life, doesn't it?
All right, it is homework time. I've laid out 5 fantastic practice problems for you here to solve and graph, directly applying everything we just went over. Do me a favor and hit pause on this explainer right now. Go grab a notebook and write these down. Seriously, active practice is how you lock this middle zone concept into your brain for good. I highly encourage you to work through these 5 problems before you close out today.
And finally, section 5, wisdom for the mind. Let's zoom back out from the algebra for a second and look at the big picture philosophy behind today's lesson.
As part of the Heroes Smart Academy Godly Learner series, we believe deeply that education has to be intertwined with biblical morality. Why? Well, because education without morality actually hurts. Think about it. You can be brilliant at math, you can effortlessly solve compound inequalities, but if you don't have wise boundaries in your personal life, that unguided intelligence can lead you into some seriously painful, extreme choices. Just like in our math problems, a healthy life absolutely requires reasonable boundaries.
And this beautifully ties into a promise from Romans chapter 8, verses 6 and 7. It promises true peace of mind to everyone who keeps their mind spiritual. When your mind is spiritually anchored, you find that perfectly balanced middle zone. You aren't constantly getting thrown off by the wild extremes of life. This isn't just some abstract theory, it's a very real, tangible experience that we see all the time when people deliberately align their academics with their spiritual well-being.
So I want to leave you with this final provocative thought to chew on today. What is the point of being incredibly smart and supposedly well-educated if we just keep making choices that hurt ourselves and others? Let that sink in for a moment. As you master these compound inequalities, I challenge you to apply that exact same reasonableness and those exact same wise boundaries to every single area of your life. Keep seeking that healthy middle zone, for sure in your math homework, but especially in your character. Thank you so much for joining me for this explainer, and keep learning with wisdom.